Today's lesson we'll be looking at chemistry 1502. The topic for today is Lewis diagram under study unit 1. We are looking at the basics, lesson 105 of organic chemistry. Let us start. In chemistry 1501, we did go through the basics of Lewis diagram and also look at the arrangement in which they are arranged on the top of the periodic table based on the Lewis dot diagram. So far we know that in group number 1, all the elements, they have a Lewis structure that contains only one dot. Like for example, we have hydrogen. Then we know that in group number 2, those elements, they have 2 dots. Group number 3, they have 3 dots, or we can say 13. Group number 14, it's a mix. 15, 16, 17 with 7 dots, 6 with 6 dots, then 8, group number 8, noble gases with 8 dots. So those are the basics. Do make sure that you watch that lesson video. Now today I'll be using a number of those elements to teach you a skill on how to draw a Lewis dot diagram. So the second element that we'll be needing for today is carbon, which is one of the most important elements in organic chemistry. And then one of those elements is oxygen, which is also important, or it's most common. And then we have nitrogen. So basically, looking at the Lewis dot diagram of this element, you can tell which group they belong. And then we have sulfur, we have sodium, then we're also going to use chlorine, fluorine. These are the Lewis dot diagrams of elements. And then we have neon. So basically we are going to draw Lewis dot diagram of compounds containing these elements, and then we'll be looking at the tricks, or let me say tips, in which you can use to draw a correct Lewis dot diagram. Let us start with our first compound. You can take this as a practice lesson video, meaning that you can pause the video, work out, play the video to verify the answer. Now we can see that we have this H2. It means that we have 2 hydrogen atoms, and then looking at a single hydrogen atom, we can see that it has only one dot. So it means that it will share that dot with another hydrogen atom. And then this will actually be like this. So you can see the only electron that it has, it will bond with that electron to form our H2. Our next example is Cl2. So Cl2, we can see a single atom of Cl2. It has 7 electrons. You can see 2, 4, 6, 7. You have 7 electrons. So in this case, you should know that it bonds with another chlorine atom. It simply means that you are going to have something like this. So each and every chlorine atom will bond with its electron. So you are going to have Cl, it's actually L here, then our Cl here. Then we call this lone pairs, since these are electrons which do not take part in the bonding. We call them lone pairs. Then these are bonding pair, or bonding electrons. So they will bond to form a single bond, meaning that you are going to have something like this. It's only one dash. One line represents a single bond. So this is the correct Lewis diagram. Our next Lewis diagram is N2. Now we know that a single atom of N2, we have something like this. It's actually like this. And then we should also bear in mind that the reason why these elements tend to bond, they are trying to reach the octet state. So the octet state, it means that it needs to reach a valence of 8 electrons. So you can see that we only have 5, and then in order to get to 8, we need an extra 3 electrons. Together with the previous examples, let us look at this. This one, as a single atom, we have something like this. It needs another electron to reach its octet state, which is 2 electrons, maximum of 2 electrons. So when we count electrons for this hydrogen, we have 1, 2. Then when we count for this one, we have 1, 2. So you can see that they're helping each other to reach the octet state. Looking at this example, we can see that the single atom has 7 electrons, and then it needs 1 extra electron to reach the octet state. Looking at this diagram, you can see that for this fluorine, we have 1, 2, 3, 4, 5, 6, 7, 8. You can see that it is identical with the next one, or the other one. It means it also reached the octet state. So in this case, we have nitrogen bonding with another nitrogen, and then they must all reach the octet state. Now we cannot bond with only 1 electron, because when we count, we can see that it doesn't reach the octet state. We have 1, 2, 3, 4, 5, 6. Also this one, 1, 2, 3, 4, 5, 6. So we need to do something. So instead of bonding with only 1 electron, let us actually bond them with 2 electrons. So this one will also come here, then this one will come here. So we actually have 1, 2, 3, 4, 5. Then for this one, it also bonds with 2 electrons, 1, 2, 3, 4, 5. Now when we count, let us check. 1, 2, 3, 4, 5, 6, 7. We have 7. Now it is identical with the next one, so we also know that it has 7. So this one cannot be the Lewis structure, this one can also not be the Lewis structure. So let us try to bond 3 times, meaning that we take these electrons, we put them here, then this one also comes here. So instead of 2, we have 1, 2, 3, 4, 5. Next one, 1, 2, 3, 4, 5. So let us count. We have 1, 2, 3, 4, 5, 6, 7, 8. So you can see that it has reached the octet state. So this is the correct Lewis diagram. Now when you write representing the bonds using lines, you are going to have something like this. Just write it in a very neat way. Let us write dual axis. So you can see it has triple bond. These are only basics. We are going to use them. This is our next Lewis diagram. We know that a single atom of oxygen, we have something like this. So you can see that it needs 2 extra electrons to bond. Now you can see if it bonds only once, we have 7. You can see that we have 7 electrons here. So in this case, we need to take this electron, bring it here, and also this one, bring it here. So we have something like this. And this oxygen also brings 2 electrons. Now when we count, you can see that we have 2, 4, 6, 8. We have 8 electrons. It has reached the octet state, so it means that we have something like this. Two electrons bonding, 2 pair of lone pairs. Now that we've went through the most easiest Lewis structures, now let us start by complicating things. We have more than 2 atoms, not more than 2 types of atoms. We still have nitrogen and hydrogen, 2 types, but we have more atoms. Now I want us to understand something. In this case, we have 1 nitrogen atom and 3 hydrogen atoms. You should know that we are going to have a central atom, an atom which is in the middle. Then you are going to have terminal atoms, which we find them just around the central atom. In this case, most cases, the central atom will be the atom with least number of atoms. Now you can see that we have 1 nitrogen, 3 hydrogen. So hydrogen cannot be the central atom. Remember that we need the surrounding, the terminal atoms. So the central in our case will be nitrogen. We put nitrogen here. And then it will be surrounded by 3 hydrogen. We can even put it here, it's fine. Now I want us to understand whether it will be double bond, triple bond, or single bonds. Now looking at our Lewis diagram, you can see that hydrogen doesn't have any other electron so that it can bond using a double bond. It only has, or it only offers, a single bond. So the properties of that hydrogen doesn't change. It also is still like this. So what we have to do now, we can put the hydrogen here, the electron of hydrogen, electron, electron. Then let us look at nitrogen. You can see that nitrogen, it can offer a maximum of 3 electrons here. Looking at this, as you can see, we did bond using double bonds, it did not work. Using single bond, did not work. Remember that we are still trying to satisfy the octet state, which is 2 and 2 for hydrogen, 8 for nitrogen. So when we bond with 3 electrons, it reached the octet state. And you should also bear in mind that it doesn't necessarily mean it should bond using triple bond. It can bond like this, as long as it bonds 3 times. It can bond like this, like for example this one, or it can bond like this, as long as we have 3 bonds or 3 lines. Same as our oxygen. But since we are busy with this, let us do so. Now if you put 1 electron here from nitrogen, another one from here from nitrogen, another one here from nitrogen, and then what is important is the lone pairs. Let us go back to this. Now you can see that once it bonds 3 times using 3 electrons, it has 1 lone pair. Meaning that for this one, it will have lone pair. For this one also it will have lone pair. For this one also it will have lone pair. As long as it has 3 lines, you should know that it has a lone pair. Those are the properties of nitrogen. Then in this case, we put here. Now looking at hydrogen, you can see that it doesn't have any lone pairs, so we don't have to tamper with anything with hydrogen. Then from here, what we can do, we can represent the bonding electrons using lines. So this is the Lewis dot diagram of ammonia. Let us look at another example. But before we go there, this lesson video is meant to address the challenges that my students are actually having during discussions. Since we have something like this, this is the central atom. We cannot have something like this. The moment you write it like this, look at hydrogen. Does it satisfy the single bond or bonding only once? No, you can see that it bonds 2 times. Also this one also okay, this one it only bonds once, but this one it bonds 2 times, so we cannot look at this. And we cannot put triple bond here. You can see that it doesn't make any sense for hydrogen. And we also don't have something like this. You can see we don't have any central atom here. And remember that we said the element with more atoms will be the central, the terminal atoms, the surrounding the central. Meaning that this one should come here or here. These are one of the challenges that my students were having. H2O. Now looking at H2O, we can see that this has more atoms, meaning that oxygen will be our central atom. So we draw oxygen, then we draw hydrogens here. Note that hydrogen has only 1 electron to offer, and then oxygen is from group number 6. It has 6 electrons. So you can see the Lewis dot diagram. Looking at the properties of oxygen, oxygen can either bond using double bonds or bond to 2. If it bonds with 1 element, it will use double bond. If it bonds to 2 elements, it will use single bonds 2 times. Very same thing applies to nitrogen. Nitrogen here, if it bonds with only 1 element, it will use 3 triple bonds. If it bonds with 2 elements, just know that it will bond using a double bond and a single bond, but 2 times. If it bonds with 3 elements, it will use single bonds 3 times. So looking at this, you can see that we can put our dashes here. Then this is the Lewis dot diagram. Then you simply put the lone pairs. You should know that if oxygen bonds 2 times, it will have 2 lone pairs. The reason why I emphasize this is that on the next lesson video, we will look at how we can form something like this when it bonds once. And we have to put a charge here. But that is not the topic for today. Let us look at the basics of the Lewis dot diagram. Our next one, we have 1 carbon, 4 hydrogen. So we can see that basically we are going to have our carbon as the central atom. Now if carbon bonds with 4 atoms or elements, just know that it will use single bonds. If it bonds with 3 elements, it will use double bonds. Double bond. Now let us rectify the misconception. Let us start by drawing the Lewis dot diagram so that I can explain what I'm saying. Carbon, it has 4 valence electrons, and then each hydrogen will be around our carbon. So you can clearly see that each and every hydrogen will be satisfied 2 electrons. Carbon will also be satisfied because it will have 12 electrons. 2, 4, 6. 2, 4, 6, 8. It will have 8 electrons, not 12. Remember that the octet state is 8. So I'm saying if carbon bonds with 1 atom, let us start with 4. If it bonds with 4 atoms, it will bond 4 times using single bonds. Like this. And then those atoms will be here. If it bonds with 3 atoms, just know that it will have a double bond and 2 single bonds. And then those atoms, they'll actually be here. Then if it bonds with only 2 atoms, you should know that we are going to have double bond both sides. Then if it bonds with only 1 atom, you should know that it will have and also this can go another way. It can be like this, triple bond and single bond. It depends on the property of the elements it bonds with. So this is the correct Lewis diagram of methane. Our next example is acetylene, which is also known as ethyl. Now you can see that our hydrogen cannot be the central atom. You know why? Because if we put the first hydrogen, the second hydrogen, it will bond with each other, and then we cannot extend the bonds because it only bonds once. We cannot extend the bonds such that they bond with carbon. This doesn't make sense. So automatically our carbon will be the central atoms. So we have C, C, and then we can check. If we put a single bond here, and then we put our hydrogens here, you can see that carbon doesn't satisfy the the octet rule, octet state. Remember, we have bonds here. When you count for this one, we only have 1, 2, 3, 4. 1, 2, 3, 4. So it doesn't satisfy the octet state. So we need to do something. Let us go ahead and put a double bond here. Now we know that for sure we have 4 electrons here. So it's 2, 4, 6. Still doesn't satisfy the octet state. But for hydrogen, everything is fine. So when you put another dash here, then we can see that we have 2, 4, 6, 8. And also for this one, it will be identical. So this is the correct Lewis structure for this. There are no lone pairs. Remember I said if this carbon bonds with 2 atoms, it's either we are going to have something like this or something like this. So in this case, looking at this one, we have something like this. The first atom is our carbon, the second atom is our hydrogen. Also for this one, the only difference is that the triple bond is here, then we have the single bond here. So basically what is important is to show the bonding electrons and the lone pairs. Let us look at C2H4, which is ethylene or ethene. So we can see that our carbons will be the central atoms. Then we have our 2 hydrogens here and our other 2 hydrogens here. So we have 1, 2, if we put here 3, which is 2, 4, 6. You can see that it doesn't make any sense. So we have to do something with the central bonding. So we have 2, 4, 6, 8. You can see now it makes sense. This is the correct Lewis diagram for ethene. Carbon disulfide. How do we draw this? You can see our central atom and our terminal by looking at the compound. Now we know that for sure sulfur, looking at the Lewis diagram, you can see that it has 6 valence electrons. It needs 2 electrons. Now remember I said these are one of the properties of carbon. If carbon bonds with 2 atoms, it's either it will be like this or like this. Now you should know that this situation only occurs when carbon bonds with 2 atoms which are identical. If these 2 are the same, just know that it will be like this. Then if these 2 are not the same, just know that we're going to have something like this. So you can see that sulfur, we have 2 identical sulfur atoms, so it means that we are simply going to write it like this. Then we should put our lone pairs. Then when you count, we have 1, 2, 3, 4, which is 2, 4, 6, 8. It is correct. Then for carbon, we have 2, 4, 6, 8. It's also correct. Then that sulfur is the same as this one, so it means it is identical. So this is the correct Lewis dot diagram. Our next one is CCl4. Now in this case, we have, the reason why I emphasize this tricks based on carbon is that we are going to deal with carbon in this chapter. When we have 4 atoms, it will be like this. So we can simply draw it and attach our Cl. Then remember that Cl, it will have lone pairs. It's correct. Hydrogen fluoride. Now in this case, we just have hydrogen bringing its electron and fluorine with its 7 electrons running short of 1 electron, then just having a single bond here. Then it's just like this. Now let us look at this particular compound. You can see that this is a bit different with the one that we've seen where sulfur is involved. Looking at this one, we can see that sulfur has more atoms than carbon. In this one, we can see that hydrogen has more atoms than sulfur. And another thing that you should know, that hydrogen can never be a central atom. The reason why is because it only can donate or share 1 electron. So in this case, our sulfur will be the central atom. If you can draw the Lewis dot diagram of sulfur, we have something like this. Then you can see that each hydrogen will come here and another one will come here. Then we are going to have something like this. Nitrogen triiodide. Definitely sure our nitrogen will be the central atom. And you can see that if nitrogen bonds with 3 atoms, we are going to have something like this. Then you simply put the lone pairs here. Then it is pretty much obvious that our iodines will be here. Then we can put the lone pairs. Done. Now let us look at more challenging compounds. Now we have 3 different types of compounds. Looking at the atoms, you can see we have 1, 2, and 4. So in this case, this will definitely be our central atoms. Now you should look at this and use it all the time. So we start with sulfur. We put sulfur here. We know that sulfur will have 6 electrons. We cannot put hydrogen and hydrogen just next to each other because it will bond with this and bond with this, and then this doesn't make sense. Remember, hydrogen only bonds once. So what we can do here, we can put hydrogen here bonding with this electron, put hydrogen here bonding with this electron. Now sulfur is one of those elements which are exceptional to the octet rule. It means they can bond and exceed the valence electrons of 8. So in this case, we are done representing this and this. Now we are left with this. What I'm actually doing here, I want to check if you can see the mistakes which students normally make. Now we have 4 oxygens. Now we know that oxygen, if it bonds with one element, it will form a double bond. If it bonds with 2 elements, it will form 2 single bonds. Yes, by the way, with the lone pairs. So in this case, we are going to put our first oxygen here, because we cannot put it here. Remember that hydrogen only bonds once. It already bonded with sulfur in this case. So if we put it here, bringing its double bond here, and then having its lone pairs here, we can see that this oxygen will reach the octet state, because it's not one of those elements which are exceptional, like sulfur. So if you can put another oxygen here, bonding with 2 electrons with its lone pairs, then you can see that we are only left with another 2 oxygen atoms which are not represented in this compound. So in this case, it clearly shows that we should do something. These ones are actually correct. We cannot tamper with them, but let us look at this. We know that hydrogen, it is only capable of bonding once. Oxygen, it is capable of bonding 2 times using single bonds. So if we can remove this hydrogen here, instead of putting hydrogen, we put oxygen here with 2 lone pairs and another electron here. One of the electrons will be here bonding with sulfur, and then we can put back our hydrogen here to bond with this oxygen. Then we do the same thing here. Then lone pairs, and then we have our, if you can check, everything is satisfied. And then looking at the actual structure, we are going to have something like this. Let us look at our last example. Now in this case, remember the trick we said, the atom with the least number of, the element with the least number of atoms will actually take the central atom. But in this case, let us compare carbon, oxygen and hydrogen. We know that hydrogen is definitely out, cannot be the central atom. Looking at oxygen, if you put it in the central with only capable of bonding 2 times, you're going to put the first hydrogen, the second hydrogen, and then it is over. We cannot represent 2 hydrogen that are left here and carbon, so we cannot consider oxygen as the central atom. Remember, it can only bonds 2 times, so it means that our carbon will be the central atom. Now in this case, carbon will bond with the first hydrogen, second hydrogen, third hydrogen, and then it simply means that here it's either you're going to put hydrogen, this one, or oxygen. So you have to decide. In the meantime, let us put these hydrogens here. Now if we can put this hydrogen, remember hydrogen, it is capable of bonding only once. We cannot put oxygen here because this must only bond once. So it means that oxygen is capable of bonding 2 times or bonding using double bond if it bonded to 1 atom. So in this case, we are going to use this because we have to bond this oxygen with our last hydrogen. So this is the Lewis dot diagram. That's it for this lesson video. This is Wahula SJ. Thank you very much.